Thanks so much. Welcome all to our, I guess it's now third meeting, as we're reading our way through the fundamentals of data visualization. This chapter is a bit short, or at least I think I'll end up making it a bit short. Having it, and it has to do with, as you can see on the screen, coordinate systems and axes. Not the most riveting of topics, but it is pretty interesting, and but this chapter left me, I think, wanting a little bit more, and maybe we'll come to that at the very end. Um, so I'll kind of go through things in a different way than the author did. I'll talk about coordinate systems, um, give a few examples, largely drawing on the author's examples, and then touch briefly on axes. Um, Also, another note is I won't go nearly into the level of detail as the author. I'll come back to maybe why towards the end, I think. So I was thinking about, coordinate systems. It sounds like a really fancy word, and what really is a coordinate system? And so I thought, let's think about it first in real life. It's just a system for placing things in space. And in this case, we're looking at an example of a chessboard. It's two-dimensional space. The images you'll see by and large are from Wikipedia, so they're public domain. So really here we have a coordinate system. We have on this axis numbers and on this axis letters, and then A1 gives us the rook, the white rook. And there are other coordinate systems, other board game ones, I guess, for the Americans or North Americans among us, the game Battleship, if any of you remember that. And then other coordinate systems that aren't, as straightforward as the foregoing two is GPS. We live that with that in our daily lives. Having some kind of coordinates of longitude and latitude that place us on this sphere that we call Earth. Um, yeah. So coordinate systems basically place things in space. And in a similar way, I think coordinate systems for data visualization purposes can kind of be thought of as systems that place, this is the way I'm trying to internalize it, that place data in space. And the space here is the kind of the visualization canvas. So here is just a really crude hand-drawn Excalibur image of let's imagine some data visualization. So we have this point that exists, and a coordinate system that places the point in visualization space. Let's imagine we have the y-axis here on the left, the x-axis right here, and then this point is at some coordinate, some x and y coordinate, and we place it into this two-dimensional space with this coordinate system. But it's a coordinate system. So like I have coordinates for this one point, but it's a system that allows me to place any point anywhere within the extent of this graph. Um, and here I'm using points, but I think we can equally think about other things. I mean, actually, this is the case in ggplot 2. Maybe it is in other systems. It happens to be that I just kind of hand drew some text, an annotation that says I am here with a line pointing to my point. But also this needs to be located in coordinate space as well, right? So where does the text occur? Where does the terminal point of the line, etc. Um, right. So I guess the canonical way of thinking about space is the Cartesian coordinate system, where you have this x-axis and y-axis, just as we saw earlier. This is the author's illustration, and that if we place any point in space, it's just a matter of the coordinates two, one, take it's one unit up on the y-axis, 2 units over on the x-axis, and then we can drop our points in that Cartesian space as kind of a two-dimensional space, if you will. Here we have a coordinate that's in kind of positive space, so it's +2 and +1, but we could also have it equally in negative, the negative quadrant. So this will kind of ring true or bring back memories of high school algebra or geometry, because it is a coordinate system. But there are also other coordinate systems that exist that are probably we don't have the habit as much, or at least I don't personally have the habit as much of thinking about, is thinking about coordinate systems where, as the author puts it, the axes are not kind of don't make a right angle, but instead they're curved. And we could have these coordinate systems with curves. So here, this looks a lot like, let's say, air traffic controllers' view of planes in the sky, and we can just have a coordinate system as well. Where we have an x-axis and then or like values will place points at particular places here, like 0, 0 will be at the center of this coordinate system. 1, 3 will place it here, etc. So we could have the coordinate systems placing things in not this kind of like space where you have x and y as these axes, but you could have different sets of axes. And here are a couple examples of it, some that are venturing more into the data visualization realm. So we could have something that would be polar coordinates. I think this chart type might be actually the um, radar chart, if I'm not mistaken. I think some people refer to it as such. So here we have months that are arrayed around this area. So January, February, March, April, all the way around in the circle. And then we have quantities of temperatures in Fahrenheit, on the Fahrenheit scale. So with this coordinate system, you can kind of see how really the shape of temperatures, where you can see that temperatures tend to be higher, so closer to the outer bounds of this coordinate system in the summer months, at least in the summer in the northern hemisphere, and then tend to be lower in the winter or fall months. And then that shape is different for different places in the United States. Chicago, not surprisingly for Americans or North Americans, having lower temperatures in the winter months than the other cities featured here. Another example of kind of these types of coordinates would be kind of geospatial coordinates. So if we were dealing with longitude and latitude, a position of something on the globe, then we could have different coordinate systems to represent that. And there are several that are available for those people that are creating maps. You can kind of map things out in a Cartesian way, where here, you've got in effect like an x and y axis with latitude here, longitude here, or you could have different projections, I guess, as they're called, like different ways of viewing coordinates in a different coordinate system. So you have the Robinson coordinate system and other coordinate systems, Mercator and others that aren't pictured here. It's simply, again, just a matter of taking a point or set of points and then putting it into uh, um, a coordinate system somewhere in space. And here space is kind of shown not in like exactly a flat plane, but let's say like a projection into a flat plane of something that's fundamentally round, the Earth. Um, and so the author talks about this chapter is meant to be on coordinate systems and axes. What I found, so this is so far I've just talked about the coordinate systems. There may be others, but these are the two kind of broad sets the author talked about. There are also axes, and I thought what was kind of interesting about this chapter is it really didn't talk too much about axes, or at least talked about them in sort of to my light, a strange way. So for purposes of this chapter, at least this is what I internalize, is that, axes really serve kind of two purposes. They tell us about the data units that are being represented, and then we'll have these tick marks along the axis that give us kind of a visual indication of how those numbers are arrayed in space. So if we're talking about this presentation and this are just, kind of a two-dimensional thing, then we could have, I guess, 0 is conspicuously missing here, but we could have, this axis of time, and maybe there's some y-axis with some other information, but axis of time, and then we could have, so we'd understand what the units are. In this case, it would be minutes. It's not seconds, it's not hours, it's minutes. So if I were to create a data visualization off of this axis, I would know the units that I'm displaying. And then for those units, I'd have these little tick marks along the way that would give me some sense of how these values were, let's say, spread across the visual space of my visualization. So in this case, I just have, let's say I have the main ticks labeled here, 1 minute, 5 minutes, 10 minutes, and these intermediary ticks not labeled, as you can easily discern what they are. Um, what I thought was interesting about this chapter is that I was hoping the author would have gone into more detail about, I guess still we're in the theory part of the book, but I was hoping for a little bit more practical guidance on how to come up with good axes, make them readable, etc. But I guess for other people that are similarly inclined that want that kind of information, this comes up later in the book, where there's some information about axes and legend titles that come up. But I felt it was kind of interesting in this chapter that has the talks purports to talk about two things: coordinate systems and axes. It didn't talk very much about axes at all, at least as such, like as the way I'm talking about axes. Instead, it seemed to talk about scales. I thought that was kind of interesting and maybe a little confusing for readers. At least for me, it was a bit confusing. Ultimately, I understood what he was trying to convey, but it was a bit confusing. That his point is that you could take data and ultimately you could transform those data into different scales if you wanted, and then show those scales on different kind of like data axes. So you could have some data that exists in this way, and you could have it on an ordinary scale, or you could take those data and transform them into so take the log of every one of these values and continue to display those data on a linear scale. Um, or alternatively, you could take the original data that haven't been transformed and then display it on a logarithmic scale, right? So you could do all of these things, but somehow it's felt like this was the author's attempt to talk a little bit about axes, but I feel like this is a lot more about scaling and transforming data. So I felt like it didn't quite have its place here so much. So I was really left wanting, for more discussion about axes here. And really, that is more or less all I had to say. And I guess I kind of wanted to open maybe to questions or discussions about what you kind of thought about the chapter, whether you've similarly felt unsatisfied with the discussion of axes, or if there, other kind of coordinate systems that you would have wanted featured here. Over to you guys.
I think to your point, there's something that I actually didn't notice on when I was reading the chapter, but noticed while you were presenting is and this is something that I think could be useful in a discussion of what an axis is and how you interpret them. I feel like these sort of linear axes intuitively make sense for people who speak languages that are written from left to right because generally like the x-axis is read from left to right and then the y-axis is read from the x-axis up being positive, down being negative. And I think that intuitively makes sense. Um, but I noticed when you were presenting the polar coordinates, the axis seems to go counterclockwise. And that feels unintuitive to me. Um, and so I feel like kind of getting back to your issue with the lack of discussion of axes, something that might be helpful would be what are the conventions around different axis types and are, for example, for here, like one thing I don't know is like, is it when you're using polar coordinates, do they always have to go counterclockwise, or could you I think you could reverse this graph to essentially have it going clockwise and it would still it would still be interpretable. So I feel like it would still work, but I don't know if that like contravenes some sort of
That's
like
that's a
statistical.
really that's a good point. think that's a good point. I mean, I can imagine now like revisiting this graph that the point of this graph is, where are the hottest places um, in the United States? And then, it's kind of obvious your eye, I think, is drawn. Oops, where did my mouse disappear to? Uh, in any event, with or without my mouse, uh, your eye is kind of drawn to the top. Well, I think at least for people that read whose languages are written from left to right, then you're going to start top left, and your eye is going to go from there. So you're going to settle on July, and you're going to see that bulge for Death Valley, right? That's so maybe here, like I don't know that it's necessarily um, a feature of polar coordinates that they're ordered in this way. Maybe, the information was ordered in a certain way to tell this particular story. If indeed that's the story that that we're meaning to tell here.
Yeah, I guess so even though I know the way that this graph uh is organized, in my head I was like, oh, it's surprising that the hottest part of the year is occurring before July, but it's not because and this is because I'm trying to read it
Yep. Yep.
clockwise. Um, so yeah. Because if you did it, if you did it clockwise, it would be the same graph. It would just, be mirrored. Yeah, I don't know. Something that I hadn't thought of until like 10 minutes ago.
I mean, I guess that could work for that particular axis because you're not what do you call it? Like there's no intrinsic order or like starting point for the months of the year, I guess. I shouldn't say. So thinking about like if I were to have numbers, there's like I have a number line, I have 0, 1, 2, 3, 4, 5, like kind of the counting numbers. I'm meant to start at 0, I guess. Here it's you don't need to start at January. And instead it seems like this is almost like this might be a confusing analogy, but if you had a bar chart, um, order the data and the visualization such that maybe the biggest values appear first, right? And it seems like that's almost to a degree like that's what's done here. It's just like that's where the starting point is. Yeah, this was another very short chapter.
It was indeed.
In reading it, it felt like a lot more of the chapter was, so I don't know. There we go. My mouse is back. It's just as mysteriously as it disappeared. Felt like a lot of the text was dedicated to this problem. Like an outsized amount of text was dedicated to this problem of kind of like scaling your data and then this interaction between the scale of your data and then the units of your axis.
Yeah. Yeah,
Maybe it's
and
just that I work in a very simple world where I don't bother with this, but it felt a little like it was too big of a side quest.
mm, yeah, I can definitely see that. I mean, I found this sort of visual representation of what a logarithmic scale or log transforming your data, like sort of the difference between the two. I found that really helpful. As somebody who like does work with log transform data. Um, but I can definitely see where you're coming from in that I don't think it's necessarily inappropriate for this sort of scale, specifically logarithmic scales, to be here. Um, but yeah, the chapter is almost more coordinate systems, axes, and scaling rather than
Yeah.
just coordinate systems and axes. It is also, I think it would be worth it to explore the fact that when we're talking about a scale here, this is slightly different than the concept of scale that we discussed in the previous chapter.
Yeah. Yeah.
They're complementary, but you can talk about a logarithmic scale outside of data visualization. But yeah.
Cool. Well, I think that's all I've got for this relatively short chapter, and I guess we've still not discussed, and it feels like that might be a Gabby thing. How to organize ourselves around the rest of the chapters. Um,
Yeah,
Personally,
we
I've
can
not had the time to look through and see if what the distribution of chapter size looks like.
yeah, I
Whether
haven't
these are
had
just the small chapters that are in the beginning, or if they're a goodly number of small chapters that could
I
be
also
merged.
haven't had a chance to look into it, but I think we could potentially um broach the question on Slack for at least next week, and see if we want to cover one or two chapters next week. I know for other book clubs I've done, we were quite fluid in terms of like extending or contracting stuff as needed. So I don't think we necessarily need to decide the whole book right now. It might be useful to for somebody to do that, but if we don't have time, like we can just do it, kind of play it by ear, and I think that's okay. Um, so yeah, we can kind of swing back around to Slack and sort that out.
Sounds good. Anyone else have any questions, comments?
No, thanks.
All right. Well,
Think I'm at
thanks
that.
for bearing with me.
No
Um,
problem. I think you did a great job.
Yeah, you
uh,
did.
thanks.